Welcome to the Crazy Hat Chemist, and here we go, the 16th video in a series of 16 van der Waals gas equation. I can't wait. Here we go. So, the reality of real gases. And if you remember back to the kinetic molecular theory at the very beginning of this unit on gases, all gas laws are based on the behavior of an ideal gas. However, there are no ideal gases. Most gases behave nearly as predicted by the gas laws, PV equals nRT. Therefore, we can use them, except under extreme conditions of pressure and temperature. So, take a look at these two apparatus. It's the same apparatus. And we're going to ask ourselves, well, the question is, at low pressures, the combined volume of the gas molecules is negligible relative to the container volume. So, on the far right-hand diagram, we have high volume and low pressure. And you can see that that plunger is very high up, and it has a large volume, and the pressure is 0. You can look at the temperature. It's 18.8 degrees Celsius. So, this is a high volume, low pressure condition. Now, if you take a look at the diagram on the right, the apparatus on the right, we have low volume and high pressure. See, there's low volume. That plunger has been moved all the way down, and high pressure under those same conditions. So what I've done is I've taken this apparatus and I've closed this system off, and then I've moved the plunger all the way down in a brief amount of time, and the temperature has actually gone up from 18.8 to 19.1 degrees Celsius. That is, I've pushed the plunger down, the volume has decreased, the pressure has increased, and the molecules of the gas molecules that are inside in that cylinder there, they're moving faster. Their kinetic energy is moving faster. They're moving faster, therefore that temperature is higher. Okay? Fantastic. So, at high pressures, gas molecules volume is not negligible. Therefore, gas volumes tend to be slightly higher than that predicted by the ideal gas equation. In addition to that, at high pressures, the attractive forces between molecules come into play at short intermolecular distances. This lessens the force that molecules collide with the sides of the container. Therefore, the gas pressure is less than that predicted by the ideal gas equation. You should pause the video, rewind that, and read that a couple of times so that you really understand that. These situations must be accounted for, these two situations of high pressure. Okay, so you should see that this is high pressure, low volume condition here. Okay, here we go. Here is the van der Waals equation. So, first of all, we need to reference the van der Waals equation with the ideal gas equation. And the ideal gas equation is right there. It's PV equals nRT. You should be familiar with that. So, how does the van der Waals equation deviate from the ideal gas law? So here is the van der Waals equation, and this is how it deviates. You should see that the right-hand side of the equation, nRT, is the same with both the ideal gas law and the van der Waals equation. But the left-hand side with pressure and volume differ, and that's the two previous slides talked about that volume-pressure differential. So this portion of the van der Waals equation corrects for the attractive forces, that is the intermolecular forces, which reduce the pressure. And this part of the equation corrects for the finite volume of gas molecules, which increases the volume. Okay? A and B are constants, and they have certain units associated with them, and they are constants associated with a particular gas. So, for example, with carbon dioxide, A is this number right here with those specific units. B is this number right here with those specific units. So whatever gas you're using, you have to look up the values of A and B in a table in the textbook or some reference data sheet of some kind. Okay, so here's some really bad gas humor now that we are done with this unit, essentially. If you pass this chapter or unit, then you can say that you have finally passed gas. There's some balloons. Here's a tank of hydrogen gas, and there is a balloon, one of those balloons filled up with hydrogen gas. Hey guys, do you want to get high? Anyways, that was the last video in this series. I hope you enjoyed this entire unit on gases. Look for previous units prior to the gas unit. Look for some other units up and coming in the future for other units dealing with chemistry. I'm the Crazy Hat Chemist. I hope you have a fantastic day. Bye now.